Hi, let's look at how we can solve the following Bernoulli equation. Um, so to simplify this one, all we need is to remember that we can write uh, this equation in the form 1 over 1 minus n. Uh, that would be dz dx instead of dy dx plus p of x, which is just a function of x, multiplied by z equals to q of x. So this is what we use to solve any Bernoulli equation that you are given, and of course it's important to remember that your z is equals to y to the power 1 minus n. Okay, so let me try to perhaps um, give a brief overview of how this come about, so that at least you know where it is coming from, even as you solve any Bernoulli equation that you can be given. You have an idea of how everything comes about. So when you talk of a Bernoulli equation, it's just one where you can write it in the standard form, uh, in the standard form dy dx plus p of x, which is a function of x, multiplied by y is equals to um, q of x by um, y to the power n, like that. So it's more like we can write it in this standard form, but what I'd want to do is that I would want to leave this q of x on its own here. Okay, and the best thing to do is just to multiply both sides by 1 over y to the power n, which is this one. I want to cancel it out. So what will happen is that I'm just going to have 1 over y to the power n multiplied by dy dx plus, that is going to be p of x multiplied by y to the power 1 minus n. How the y to the power 1 minus n comes about is that I got this y and I said y divided by y to the power n. Since the bases are the same, just say y is equals to 1. No. We say this is equals to y to the power 1 minus n. You have a 1 here. Since they are dividing each other, this one is going to subtract this n that is down here. That's how I came up with a y to the power 1 minus n. Then this will just be equals to q of x. Okay, so coming to this one, how that one comes about is that you observe that I have a dz here, but I have dy dx. So where there's dy dx here, I would want to substitute with what dy dx is in terms of dx. And how you come up with it is that you have to differentiate what you have here with respect to x. Okay, and what you're going to get is that this is just going to be more like you're going to say dz dx will be equals to um, this is going to be equals to dz dy multiplied by dy dx. Okay, so now I this here is what is at this point. Okay, so for me to properly substitute, for me to properly have dz dx here, I have to find what my dy dx is. I have my dy dx here, so I have to make my dy dx the subject of the formula. But before I do that, let me try to find out what my dz dy is. So I have my z here, so if you differentiate this with respect to y, you're going to say this will be your dz um, dy being equals to, you're going to drop the power. This is just simple differentiating, so that would be 1 minus n y to the power 1 minus n minus 1, like the power reduces by 1. And one thing that you observe is that this can cancel and that one can cancel there, hence you just have what, you just have minus n, like that. And this you can simplify it by saying your dy, sorry, you can simplify it by saying your dz dy will be equals to 1 minus n divided by y to the n. I want to get rid of the negative there. Okay, so I can bring it here and say my dz dx will be equals to my dz dy are found 1 minus n to the power y to the n dy dx. And all we have to do is just to make dy dx this dy dx, the subject of the formula. And how you do it is that you can just multiply both sides of this by y to the n divided by 1 minus n, so that you cancel out that, and you end up having your dy dx being equals to dz dx multiplied by y to the n divided by 1 minus n, like that. So you can come and substitute your dy dx at this point here. Then let's see what we're going to get. So we're going to say 1 over y to the power n multiplied by, what is our dy dx? We have found that is dz dx multiplied by y to the n divided by 1 minus n. Okay, so I've substituted here where I have dy dx, and that would be plus p of x. And remember to say your y to the power 1 minus n is nothing but a z, so you can put z here is equals to q of x. Okay, so one thing that stands out here, that this can cancel out and that can cancel out, so this just ends up to be 1 over 1 minus n, which you can put in brackets. Then you have your dz dx plus p of x, z is equals to q of x there. So this is what you're going to use to solve your Bernoulli equation, and you're going to use the integrating factor method to solve this one. So we are going to solve it in terms of z at first, then we have to take it back in terms of y. Okay, so let's see how this unfolds. So one thing that we have here is that we can say 1 over 1 minus, so we have to know what our n is. So if you look at this here, that is what our n is. So our n is equals to minus 3. So in fact I can find my z in advance. So my z is equals to y to the power 1 minus n, and this is simply y to the power 1 minus 3, and this is just what, y to the fourth. Okay, so that is what our y is. That is just y to the fourth, like that. So you can put the same minus 3 here, and it's just going to be positive, so that's going to be plus 3, and that's just going to be a 4. Okay, that's just going to be a 4 down here. So we'll have a 4 by dz dx plus, what's our p of x? Our p of x is what you have here, which is x is equals to, your q of x is what is here, which is x e to the minus x squared. Okay, so you're supposed to leave, for you to use the integrating factor method, you're supposed to leave dz dx on its own. So what you do is that multiply both sides by 4. So this is going to be dz dx plus 4x. By the way, you're going to have a z here, so it'll be a z there, like that, and this will be equals to 4xe to the minus x squared, like that. So now let's use what we have now to get what we want by using the integrating factor method. So all I need to remember is that my y to the fourth is equals to z. So here to use the integrating factor method is pretty simple. You just have to know how you come up with your integrating factor. Okay, so what you do here is you're going to say your integrating factor. I like indicating it by saying if for integrating factor, which is going to be equals to e to the power the integral of p of x dx. So this is going to be equals to e to the integral. What's our p of x? Our p of x is 4x here, so I can put the 4 then x dx here. Okay, so the integral of x is nothing but x squared over 2. So you observe to say this is multiplying 4, so 2 there, 1, 2 there, 2. So your integrating factor your integrating factor is just equals to your integrating factor is equals to e to the 2x squared, like that. Okay, that's what we have as our integrating factor. Then to get our solution, okay, to get our solution, we are going to say, because I'm finding in terms of z, so I'm going to say my z is equals to, by the way, I'm finding in terms of z for now, but initially I'm supposed to find in terms of y. So this will be equals to the integral of the integrating factor, which is e to the 2x squared, multiplied by q of x, which is that one there, which is our 4. So I can put the 4 outside, then that would be x e to the minus x squared. So you observe that you have your e here and e there, so the bases are the same. You can add the powers, so that is 2x squared minus um, x squared. So it's more like 2x squared plus minus x squared. You're just going to get x squared there. So this can simplify to, I can say I have x e x squared, like that, dx. So we can go ahead and integrate that one. So one thing that I realize is that I can use u substitution to integrate this one. I don't have to waste my time thinking about um, integration by parts. So I can use u substitution. So I'm going to let my u be equals to my x squared, which is the power of e. So my du is going to be equals to 2x dx, meaning my dx is going to be equals to du over 2x. So we're going to say our z is just going to be equals to 4 multiplied by, there is this 2 here, which is going to be 1 over 2, of which 2 into 4 is a 2. Then here you're supposed to say x e to the u, then du over 2, sorry, du over x, then it cancels out there, so I don't even need to put it. So this can just be e to the u du. Okay, so your z is nothing but 2e to the u. What is our u? It's x squared. So we are not yet done here, so we have to multiply what we have by the integrating factor. Okay, so we're going to say integrating factor multiplied by z is equals to what you have here. And by the way, we are going to add a c here, like that. So this is going to be 2e x squared plus a c. And one thing that I can do here is that instead of me using z, I can write in terms of y. I've found out that my z is equals to y to the fourth, so I can put y to the fourth here. And my integrating factor, we found e to the 2x squared, like that. Okay, so now what we do here is that I can multiply both sides by 1 over e to the 2x squared, so that I cancel out this one and that one, so that I just remain with y to the fourth. Of course, I have to write it in terms of y when I'm done, because I'm not looking for y to the fourth, but just y. So this is just going to be y to the fourth equals to that will be equals to, okay, I will not need to simplify this one. You can simplify it on your own. I'm just going to write it as my 2e to the x squared. Okay, e to the x squared plus c. Then this is going to be divided by this one here, which is my e to the 2x squared, like that. Then to write it in terms of y, not y to the fourth, I'm going to say the fourth root of which is the same as just writing 1 over 4 here. Then I do the same here as 1 over 4. So my solution is just going to be y is equals to 2e that would be 2e to the x squared plus c divided by that would be divided by e to the 2x squared, like that. And this is my solution right here. So that's basically how you go about that. We can try to simplify this one, maybe divide this one by this one, then c by that one there, so you see what you're going to get. But otherwise, that's how you go about answering Bernoulli equations. And I believe it's now clear how this one comes about. It does not just come from nowhere. It's a fact that we can write the Bernoulli equation in standard form. Then you bring it to that, like instead of you using dz, instead of you using dy dx, use dz dx, so that you use the integrating factor afterwards. Then you bring it back in terms of y. Yeah, so that's all in this video. Thank you very much for watching, and we'll catch you in the next one.